Welcome back, everybody. This is part 3 of the Fisher Studio Standard repair series that I'm uploading to YouTube. This was all shot in 2014. You'll notice in the background that I was doing this the same time that I was doing the Kenwood Care 9940, the recap job on that. For those of you who've been with me since the beginning of this channel, you'll remember that video that I did of recapping that beautiful Kenwood 9940 quadraphonic receiver. So this video is going to be about rebuilding the amplifier section, and I'll let you see how that turned out. Well, I went ahead and decided to go ahead and pull the amplifier out of this unit. And it's interesting the way they did this, because this whole unit comes out from the back of the chassis right here. It's screwed in around there. I've had to pull the bottom cover down and unscrew this power supply board right here so I get enough play in this to be able to pull this out of here, twist it out, and then get it out of here. This transistor, when it blew, it also was kind enough to go ahead and blow these transistors as well. So I'm going to have to order some transistors for this guy, and I'm going to go ahead and replace all of these transistors, including the same 3 on this side that got blown over here. And the reason that I'm going to do that is because the modern equivalent to this transistor is rated for 200 watts of power. Now, I don't expect this receiver to deliver that kind of power, obviously, but in order to keep the power equal to both channels, I'm going to have to replace both of these transistors. And I'm going to replace all of these transistors, the other 3, on this side as well, to try to keep everything equal as far as the transistors goes for the output stage of the amplifier. Everything else checks out fine on this. I'm also going to go ahead and replace these capacitors, even though I don't really believe that they're bad. Since I'm going to go ahead and resolder this anyway, I'm going to go ahead and replace these with some Panasonic FC series. And I'm also going to go ahead and do a partial recap of the power supply. I'm going to replace these big capacitors along here. The main filter caps I'm going to leave because these things are $8 a piece, and I don't really feel like paying that. So I don't really think they're bad, but I figure a partial recap job might be pretty good. I'm going to use Panasonic FM series for these down here. I'm also going to go ahead and replace all the fuses, 2 back here and all these down here, just to freshen those up a bit. Just even though they're not blown, it's just nice to have some fresh fuses. And then I'll save these fuses for test fuses in the future. It's interesting about Fisher. Fisher was bought out by Sanyo, and Sanyo is owned by Panasonic. So I figured it was fitting to use Panasonic capacitors in this unit. Also, it's interesting that when I looked up these transistor part numbers, they actually came up as a Sanyo part number, so that's interesting. If this was not a Fisher, or if this amplifier was rated at only 20 or 30 watts a channel, I wouldn't bother with this. But Fisher equipment is valuable and it's rare, and because Fisher is essentially not even around anymore because Sanyo bought them and Panasonic is apparently phasing out the brand, and I read that on Wikipedia, so who knows how accurate that is, but I bet you it's probably true. You're not going to see Fisher equipment anymore. So I think that this is definitely worth putting some time and a little bit of money into. I'm not going to put a whole lot of money into this because I really don't know what I'm going to have when this is all said and done. If I have something extremely kick-ass, though, I may go ahead and do a full recap on this bad boy. This thing has mostly Shui capacitors, if I'm pronouncing that right. I have never heard of that brand. So there are some Rubicons The only Nichicons I found are these right here. Everything else is either Rubicon or these Shui brand of capacitors, but I think there might be there's a couple Rubicons down here. I don't remember which one of these are, but there's really not a whole lot of capacitors to replace in this thing, so other than the main filter caps, it really wouldn't be a whole big expensive job to do so. And being that this receiver, or this amplifier I should say, is more than 15 years old, it's probably a good idea to start thinking about replacing these caps if I plan on using this for any extended period of time. But we'll see what we got. So I'm going to place that order, and I think I'm going to tear apart the tape deck, and maybe that'll be a separate video, because that thing's all gummed up and there's all kinds of dirt in it and stuff like that, and it ain't working. So, but this would be probably a pretty interesting system to have all together once it's said and done. So it's going to be a couple days before I get parts in, so we'll hit you back when I get them in. I also need to replace the two light bulbs back here that are burned out, and I'm going to put some LEDs in here. I'm going to try some different LEDs in here. I also need to check and see what the voltage is coming off of these leads, and see what if I need to put a resistor in there, or if the LEDs that I have is going to work fine for this without any kind of modification. I don't know if I don't see any other lights right now on this amplifier, but there might be some over here. I'm not entirely certain, but we'll see. I know this one's definitely out though. Well, I got all the parts in from Mauser to fix this Fisher amplifier right here. I started by removing the transistors on here. I stopped when I got to this one and decided I need to start filming this, so here you go. I went ahead and marked on here the transistors that were in these two places, so I know automatically that the opposite one was the one that I didn't mark. I also went ahead on the list here of parts I ordered and wrote down the original part number that was in the amplifier for the corresponding new replacement part that I ordered, so I knew which one went to where. And that was this sheet that I made right here of all the values and capacitors and transistors and the part numbers and the brands that I ordered and stuff like that. I also did a quick diagram draw out here, the layout of the transistors. Some of these I just wrote down, but I'm not replacing them, so I know where they're at. And I also made sure to keep track of, there's this symbol right here on the circuit board on the amplifier where the transistors go. So I made sure to keep a good visual record there of which way those transistors were facing versus the way it shows on the diagram on the circuit board itself. So I know right away which way to put them in, so I don't put them in backwards. So I'm going to go ahead and finish. I've already got all these soldered. I'm going to go ahead and finish taking this out. It's interesting that this receiver, built in 1986, all the thermal compound is still gooey. Hell of a good thermal compound, I guess they used, although they didn't they didn't care about how much they put on, apparently, because it is a sloppy mess in here. But I'm just going to go ahead and put a little bit of new stuff on the surfaces of these insulators here, and they'll be good to go on that. One freshly recapped amplifier board. Transistors are replaced. And I just got to put it back in the heat sink here, apply a little thermal compound to those two, and we'll go ahead and get those other transistors mounted on there. Getting closer. Well, we have reached the part of this repair video that I need to stop and explain a few things. I could edit this stuff out of the video or decide not to record it at all. However, part of training videos or repair videos or whatever you want to call these is sometimes more beneficial to learn from other people's mistakes. Hopefully you won't make the same mistake that I did. So I went in and I put all the new transistors in, all around there. Also went and recapped it. I pushed the power button. It came on. I checked my voltages, and I was right on the money. So I decided to hook up the speakers and the CD player. And lo and behold, it was playing music. And boy, did it sound very, very good. It was really thumping those RTRs right there. So I decided to test the bass and treble adjustments and the loudness. And when I pumped up the bass just a little bit, and that's when, of course, the magic smoke and the genie who lives in the lamp got blown out of his lamp, so to speak. He had feet and arms just kind of coming out, just kind of dangling out of the lamp there. So what happened was that ended up blowing one transistor, all the fused resistors around here, and it took me more hours than I care to admit to try and trace down everything that had gotten fried. What happened was I didn't replace these diodes right here, and there's 3 of them in this unit. There's one there, and there's 2 back here. There's one down here, and then there's one soldered to the back of this board right here. All 3 of those, or at least after the amplifier blew, were all shorted. So I figured that at least 1 or 2 of them, or probably all of them, were in fact shorted out. And because I had not checked that before I started testing it, I only got about 2 minutes before the magic smoke finally blew out of it, and it died again. What threw me for a loop was that after that point, I had 63 volts pouring out of all of this on this side of the amplifier, which is the left channel, I believe. Left or right, I don't remember. Anyway, it doesn't matter what side this is. And it also fried, well, it didn't fry, but it started to try anyway. There's a resistor right down here that goes to the headphone jack. So, needless to say, it took a long time to trace out, after replacing these diodes and 1 transistor, and I did find 1 bad solder joint that I had to refix. The traces on this board are not great, and they seem to be coming off with a little bit of heat to them, so I had to be very careful. This one I didn't even know about. But anyway, suffice it to say that tracking down why it was dumping out 63 volts ended up being a real trouble, because normally when that happens, it's usually a shorted out transistor somewhere in the circuit. And that wasn't the case here. Ended up being, going all the way back to, let's see which one here, this one right here, this transistor. There is a fusible resistor right here that I didn't think about even bothering to check, because I was thinking of this side forward. I wasn't even thinking about this side. And these 2 transistors here end up supplying the bias voltage to this amplifier. And because this transistor wasn't getting I don't remember if it was the base or collector or which voltage it was, because it wasn't getting that, it was all the rest of these were just dumping out 63 volts by default. So once I found that, I don't have any fusible resistors, so I had to find the closest resistor out of another receiver. A receiver donated its magic smoke to fix this amplifier. So I've got a 22 ohm. There's a 22 ohm fusible resistor down here. There's another one somewhere in this circuit. I can't see where it's at right now. And then there's this guy over here, and he's an 82 ohm. So I found some resistors that match the ohm anyway. Even though they're not technically fusible, they still work just fine. So the problem that I have now is that the voltages are fine, and I haven't let any magic smoke out yet. But the problem with the unit now is that, well, I'll just go ahead and plug it in here. Let me see if I've got anything here that's going to give me a bad day or not before I do. And that should be okay there. So the problem here, and I'll show you this, I'm going to go ahead and plug this guy in. Let me see if I can find the right power cord here, which is starting to become a real hassle. Okay, so that's what happens when I turn it on. Now if I turn the volume all the way down, display goes wacko on it. And you can see the loudness button also lights up. So something got zapped over here as well in the control. And there is some voltages coming out of the amplifier, these three right here. One of these, anyway, goes back into here. Actually, all 6 of them go back into there. So it could be either any one of these. I'm hoping it's a bad diode or something like that that got hit when 63 volts started dumping into all this stuff. But that's why I haven't plugged any speakers up to it yet, because I honestly don't know if this is controlling the volume or not, and I don't want to plug speakers in when I've got 100% volume dumping into this thing. So, shut that off. But I didn't let any magic smoke out. Anyway, here's the lesson to be learned from my mistake, folks. When you work on these things, always, 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 always check for shorted diodes. Because if you don't, and there is a shorted diode, it's going to give you a very bad day like this did. As a matter of fact, like I said, it was more than a day, more than 2 days worth of tracing this and pulling this amplifier in and out of here before I finally figured out where the problem was on this thing. Something simple took a long time to trace back because there was a lot of components here that could have been causing a short. And that brings me to the other thing that I found interesting, because I had to obviously print out service manual for this. And the main power transistors on the back of this thing, or final output transistors, however you want to term this, were all Sanyo parts. These guys right here. And I replaced all of them. Now, when I looked at the cross-reference, listed, I don't remember what the part number was, but they were, the old ones were a 120 watt transistor, which would match the 120 watt maximum rating on the display right here. Now, according to the service manual, although I have the only service manual I have is for the 870, not the 871. And the 870 looks like the European version of this unit, and it has a little bit of extra goodies on that amplifier board right there. It says that this amplifier is rated for 100 watts per channel. Minimum 100 watts per channel is what it says. So, I said earlier in this video that I found it interesting that they only used 120 watt transistors in this for what I was assuming was probably a 100 watt amplifier, 100 watt per channel. Well, the interesting thing is that the service manual, you go over here to the main amplifier, Q1 through Q4 right there are those main amplifier transistors. And those are the exact part numbers that I put into this that came up on the cross-reference, not what was in here. So these are a Sanyo part, and since Fisher, I'm not sure if Fisher was owned by Sanyo at this time. I think this was built in '87 sometime. I don't know if they were owned yet by Fisher or by Sanyo or not, but I know Sanyo was building these things for Fisher back then. So all these parts in here are either Sanyo or they have a Sanyo part number to them. But I find it interesting that the service manual references the exact transistor number that I put into this that came up just as a cross-reference. And I find that interesting because I'm kind of wondering if, except for the fact that I blew it up the second time with not having those transistors in there, or the diodes in there correctly, because I didn't replace them, so it was creating shorts in here. I find it curious because I wonder if this is actually a design flaw. Because this thing is rated for a maximum, according to this anyway, of 120 watts, and these are 120 watt ICs, which means these things were running pretty much damn near close to their peak rating, even if you figure it at 100 watts. And I'm kind of wondering if this was an early model that they produced and they had problems with those transistors blowing down there, and so they revised in the service manual the 200 watt part number that I ended up putting into this to solve that problem. Curious, I haven't been able to find anything to prove whether or not it was speaker terminals that shorted out back here that blew it out, or if it went on its own. I'm kind of guessing the damage, though, the ripple of transistors that blew, and that blew these fuses as well. I'm kind of thinking that it may have actually been a design flaw, that when you crank this thing up to a certain point and you've got the bass pumping, and believe me, this thing was pumping out some serious bass even when I raised it just about 2/3 of the way there. It was definitely hitting these speakers hard. I could see it overdriving those transistors possibly, or definitely shortening their life. So I'm kind of guessing the transistors just shorted out because they were running at pretty much their rated maximum, and that was it. That's kind of what my theory is. But anyway, I've got a little bit more work to do. I hope I can fix this problem, though. I'm sure I can. Now, it's interesting, there's a lot of Toshiba ICs in this they use for controller ICs and whatnot. There's another one over here in the input board, and they're all Toshibas actually. I can't really read this one down here, but anyway, I've got one problem child solved, so I created the other one, so I'm going to have to fix this one now. And I got to also finish putting the lights in. This is another interesting thing about in the service manual. Service manual, this thing has 2 bulbs in it. The service manual says that these bulbs are in series to one another. So voltage comes into one, goes over to the other, and then comes back out. This is not how this is actually wired. There's actually a resistor right here under this heat shield right here, which I find is rather interesting that they put a heat shield around that. And then the other 2 wires that go into ground, and both lights are wired to those terminals. So they're running in parallel, not in series on this actual amplifier. And I don't know if that's just something they changed, a design that they changed for the European model or what, but I found that I've got about 17 or 18 volts coming out of these leads. When I hooked up a 12-volt bulb, it didn't blow it, but I was running at about 15 volts. So I'm guessing that if I put the second bulb here, these will probably be running it right pretty close to 12 volts in here, I'm guessing, because that resistor down there is probably sized to limit the amount of current based on what the milliamp rating of the bulb is. So I'm guessing that you get 2 bulbs fed off of that resistor down there. It's going to reduce the amount of current going to both bulbs. So hopefully it'll run at 12 volts, and I'll just be able to use 12-volt bulbs in this. But that'll be something I'd finish at the end. So I'm going to get back to this, and it's actually kind of nice. This thing just snaps in here. There's some little push clips in there, and this whole thing comes out. At least I can get to the slider controls really good, so I can get some deoxit in there and clean those up really good. Clean the balance control as well. So progress continues on the Fisher 871 amplifier.